The objective of this practice is to determine the amount of energy absorbed by a material during fracture by the Charpy impact test, and to study ductile-brittle transition as a temperature effect on materials. Procedure, we are going to use the impact test machine, and first we need to drop the machine alone to calculate the resistance. Approximately the air resistance is 19. We set the machine again to the top and set the first sample, that is 10.5, in this position. And it's like 48. Now the 1018. We need to set again the indicator. And it's like 47.
Now, here we have our last sample, and we are going to look at this new testing. Now we are going to
These are our results for the practice of impact test. We made 2 tests for each steel at different temperatures. First, for 1018 and 1045, we made the procedure at room temperature, and later we made it for a lower temperature. To calculate the energy absorbed in the materials, we use the force resistance that the pressure gauge gave us, minus the air resistance. And we have the energy absorbed in joules. We could observe also the kind of fracture that each material had. For example, for 1018, we have at room temperature we have a steel fracture. Also for the 1045, and for the lower temperature we observe a brittle fracture. In this practice we could determine that not all the metals, in this case the steel, can have the ductile to brittle transition at the temperature. For example, BCC metals have transition temperature and FCC do not have it. Steel is an alloy of iron and carbon, which improves the properties of the iron. It means less carbon, less resistance, and more ductility. More temperature requires more energy to break the material. Also, it will be more ductile. And with less temperature, it breaks with less energy. Impact resistance decreases with an increase in the modulus elasticity, which means the stiffer materials will have less impact resistance. Resilient materials will have better impact resistance.
In this practice, we have important concepts is good to know, and one among them is impact resistance. This is the ability of a material to withstand a high force or shock applied to it over a short period of time. High force over a short time has a greater effect when a weaker force over a longer period of time. As we can see in this image, impact thoughtness depends on time and a load. The Sharpie impact test determines the amount of energy absorbed by a material during fracture. This absorbed energy is a measure of a given material's notch thoughtness and acts as a tool to study temperature-dependent ductile-brittle transition. It is widely applied in industry since it is easy to prepare and conduct, and results can be obtained quickly and cheaply. The disadvantage is that some results are only comparative. The ISO impact test is very similar with our Sharpie impact test, but uses a different arrangement of the specimen under test. The ISO impact differs from the Sharpie impact test in the sample is held in a cantilever beam configuration, as opposite to a 3-point bending configuration in Sharpie test. And here is the force that will break up the sample.
In the impact test, we have two different types of fractures. The first one is the ductile. There is a type of fracture characterized by extensive deformation of parastic or necking. The term ductile rupture refers to the failure of highly ductile materials. In such cases, materials pull apart instead of cracking. And this is an example of a ductile fracture. In the other hand, we have the fragile fracture. Occurs with a little or no gross plastic deformation and take place along the crystallographic plane. It's for BBC and HCP file in this method. It's a fracture of a metal or outer material without appreciable prior plastic deformation. It's a break in a brittle piece of metal which fail because stress exceeds cohesion in brittle fracture. Cracks run close to perpendicular to the applied stress. The temperature of transition from ductile to brittle is at which the failure mode of material change from ductile to brittle fracture, defined by the average energy between the ductile and brittle regions. No all materials have a distinct... Ne, amor, neta. A ver.
Vale.
¿Lo cortaste? No, si quieres déjalo. Ya, okay. No all materials have a distinct transition temperature. BCC metals have transition temperatures, but FFC metals do not. The temperature of transition from ductile to brittle is in the way. The temperature of the temperature of transition from ductile to brittle. No, ya corta.
Eso no fui yo.
Finally, this test serves to break failures in constructions of products if they were made by certain materials. Also, to observe the behavior at specific temperatures. Yeah.
In these days, security is an important and valuable concept that we as customers care about. In this practice, I learned that it's very important to determine how strong is a material and how the nature of the sample and the temperature determine the behavior of the metal.
In this practice, I could understand the importance of impact tests in the industry, especially for a part design. It is very important to do every step well done to make a safety product and to check all its mechanical properties.
In the practice, the most steps were done by us, so I could observe very closer all the process, and we could prove the properties related with the temperature to the impact test.